Okay, so we're going to prove this one rigorously. Now, I'm not going to rewrite the steps here, but if you forgot them, go back to the other video and write down the steps. I'm sure you wrote them down already. But the first step, if you remember, is to write down f of x minus L is less than epsilon, which is what you want. So x squared minus 3x plus 2 is less than epsilon. This is what we want. And x minus c, or x minus 2, is less than delta. This is what we know. Okay, step 2 is to use algebra to write down a this guy, f of x minus L, in terms of x minus c. So notice that f of x minus L, x squared minus 3x plus 2, this guy you can factor into x minus 2 times x minus 1. Okay, now this guy right here is x minus c. This one we have total control over, so we don't have to worry about that one. This one, though, this guy right here, we do have to worry about, because we don't have control over this guy right here. So this is the third step that I was talking about. We skipped it last time, but this time we're going to have to bound this one. And so what you do is we're going to assume, since you already know that delta is going to be small, in other words, x minus c is going to be small, then, and if it's, if making it smaller doesn't hurt the proof, let's just assume that x minus 2 is going to be less than 1. So you're just assuming that it's going to be less than 1. And so if it has to be smaller, then we make it smaller. If delta can be bigger, then this doesn't hurt it at all, because the smaller the x gap, the better it is. So assume that that's the case. Then what this means is that x minus 2 is going to be between 1 and negative 1 if you break up that inequality. And then if you add 2 on through to everything, what you get is x is going to be between 3 and 1. So now if x is going to be between 3 and 1, then what that means is that absolute value of x minus 1 is going to have to be less than 3 minus 1, which is 2. Now why 3? Well, notice that the biggest x can be is 3, so that means that the biggest x minus 1 can be is 2, right? Okay, so if x minus 1 is less than 2 by this assumption, then what that means is that x minus 2 times x minus 1 is less than 2 times x minus 2. So just a straight substitution of, instead of absolute value of x minus 1, well, that's less than 2, so just make it less than 2 times x minus 2. And see, now what you have is you have a constant times your x minus c, and you can work with that. So that was the whole point of doing this assumption, is that you're bounding this x minus 1 that you don't have control over. Okay, so step 4 is to figure out what you want delta to be. So you grab your f of x minus L from the previous step, and you set that less than epsilon. And remember, what you do is you solve for x minus c. So I'm going to solve for this guy. So that means that I want x minus 2 to be less than epsilon over 2. Okay. So then you choose step 5, delta to be equal to that value that you just found. Okay, so then you're almost done. Step 6 is, actually maybe I should just go down so that I can see more of my stuff. Step 6 is going to be where you just restate everything. So since x minus c, or x minus 2, is less than delta, or epsilon over 2, then what that means is 2 times x minus 2 is less than, the 2 is this exact 2, and then x minus 2 is less than epsilon over 2, and so this is equal to epsilon. And that's it. You've proved it.